Nowadays, biohydrogen is seen to be one of the developable renewable energy. Burning hydrogen only produces water and doesn't produce any greenhouse gases. So not only is it environmentally friendly, but it also displaces fossil fuels that are becoming less available. And our research uses wastewater to produce hydrogen because paper mill wastewater has a lot of cellulose, which reacts with muriatic acid and then produce glucose, which is the common source the bacteria need for growth. And these are our specific aims. One, to explore the best proportion between stored phase sludge and substrate. Two, to compare the concentration of reducing sugar of paper mill wastewater. Three, to find the best muriatic acid concentration of acid hydrolysis of paper mill wastewater. Four, to find the best pH value of hydrogen production and estimate the hydrogen yield. Five, use the liquid chromatography to analyze metabolic product in different pH value. And this is our 12 wastewater recycling ideas and planning. And up here is the steps of paper making. The wood pulp and waste paper goes through the pulp preparation system and the paper machine, and then out comes the finished paper. And down here is our recycling ideas and planning. If we can use paper mill wastewater and contains it with sludge, which has hydrogen producing bacteria in it, and after the dark fermentative hydrogen production system, we can get hydrogen power. So not only we can decrease the using of fossil fuels, but we can also reduce the sewage damage. And this is our experiment flow chart. And our goal is to find the best conditions for hydrogen production. First, we find the optimal proportion of sludge and substrate, and use this ratio to do experiment 4 and 6. Next, we use 10% muriatic acid to hydrolyze wastewater which hadn't been recycled cellulose. And because to see that if we have to hydrolyze it or not. And the result tells us that the wastewater after hydrolyzed has more reducing sugar. So next we test that the best muriatic acid concentration to hydrolyze wastewater and use concentrated wastewater to reward the experiment can help us see the accuracy of our experiment.
This is flow chart 1. Conduct batch hydrogen production experiment. First, we prepare the substrate. Then we mix substrate and sludge by volume 1 to 1, 1 to 2, 1 to 4, 1 to 6, and 1 to 8. Then we adjust the pH value to 5.5. Then we expose in nitrogen for 3 minutes. Then we incubate in the orbital shaker incubator. Finally, we collect and record the hydrogen production 2 times a day for a week. This is the inorganic salt in the substrate. This is flow chart 2. Apply 10% muriatic acid to hydrolyze wastewater. First, we use paper mill waste. First, we collect paper mill wastewater and separate them into muriatic acid hydrolysis and non-muriatic acid hydrolysis. Then we through this process, we finally record concentration analysis result. This is flow chart 3. The best acid hydrolysis portion of muriatic acid concentration of paper mill wastewater which hadn't or had been recycled cellulose. First, we use paper mill wastewater which hadn't been recycled cellulose and had been recycled cellulose. Then we add muriatic acid. The muriatic acid is 2%, 4%, 6%, 8%, and 10%. And through this process, we use a spectrometer to measure the concentration and record the data. This is flow chart for the best pH value of hydrogen production of paper mill wastewater, which hadn't or had been recycled cellulose test experiment. First, we calculate the substrate with paper mill wastewater which hadn't been recycled cellulose via acid hydrolysis. Then we use a 2% acid hydrolysis. Then we through the process, we collect and record the hydrogen production. This is flow chart 5, the best acid hydrolysis proportion of muriatic acid concentration of the concentrate of paper mill wastewater which hadn't recycled cellulose. First, we concentrate on paper mill wastewater which hadn't been recycled cellulose. Then, through the process, we use a spectrometer to measure the concentration and record the data. With flow chart 6. The best pH value of hydrogen production of the concentrate of paper mill wastewater which hadn't recycled cellulose. First, we calculate the substrate with the concentrate of paper mill wastewater which hadn't been recycled cellulose. The acid hydrolysis. The acid hydrolysis is 2%. Then through this process, we collect and record the hydrogen production. Then we can use the gas chromatography to see the hydrogen production, and we can use the liquid chromatography to see the liquid metabolite. This flow chart 7, the bacterial analysis. This is flow chart 8, the chemical oxygen demand analysis. COD is the consumption of oxygen when using chemical waste to oxide organic waste. We first do this process, then we put into the formula to get COD value. This is the formula we use.
From this chart, we can see that the best proportion of the substrate in the sludge is 1:1. And reducing sugar concentrations that haven't been recycled is higher. The paper mill wastewater both have been recycled and hadn't been recycled have the best production in pH 5. The best watery acid hydrolysis muriatic acid for concentration is 2%. We can see the best pH value of the paper mill wastewater which hadn't been recycled cellulose is pH 5. In this chart, if acetic acid and propylformic acid has more production and it has better hydrogen production yield. on this chart, we can see that pH 5 has been the best. We can, in this picture, we can figure out the bacteria in the spore, bacteria cases, entomologists, genus, and Australia genus. The concentration of COD value after produced hydrogen is lower.
Conclusion. The best proportion of the substrate and sludge we found is 1:1. The best pH value of hydrogen production of paper mill wastewater is pH 5. The best muriatic acid concentration of acid hydrolysis is 2%. The reducing sugar concentrations of the concentrated of paper mill wastewater which wasn't recycled cellulose is higher, and its hydrogen production is also much higher. Then calculating with large amounts of wastewater, the feasibility of this plan and the possibility of development in the future are considerable. Not only can we promote environmental protection, but also can use power of hydrogen to reduce costs and make the paper factory turn to a green factory. We even can bring it up to a level to design a continuous device to breed the microorganisms in the sludge, fixed amount to input the substrate, and make hydrogen production the highest benefit out of it. After doing the analysis, we can know that our sludge contains Clostridia, a kind of dominant hydrogen methane bacteria. Hence, it can prove that our experiment had true bacterium. After analyzing the COD, we found that after producing hydrogen can effectively decrease the COD value of paper mill wastewater. It means that besides the benefit of producing hydrogen, it also can remove the organic waste in the wastewater that can be more conform the legal standard of drinking water and can make the double benefit to the goal of living up to the green factory. Thank you for listening.
你那个第一个 flow chart one， 你用一个 hydrochloric acid 跟后来